Hello everyone, I'm Srikar Kompella. Welcome to the Site Reliability Engineering Conference of 2025. Today we're going to discuss about transforming monolithic SaaS, the serverless revolution on AWS. Welcome to our comprehensive exploration of serverless migration strategies for SaaS applications using AWS. This presentation will guide you through the journey from monolithic architectures to flexible microservices that can dramatically reduce your operational cost while accelerating development cycles. We'll examine practical implementation steps, real-world success, and critical considerations for security, business intelligence integration. By the end of this presentation, you will have a clear roadmap for your own serverless transformation. Now, let's say why migrate to serverless architectures. Serverless architectures deliver compelling benefits that extend far beyond the simple cost savings organizations migrating from monolithic systems report dramatically reduced operational overhead. So with typical cost reductions ranging from 30 to 60% in some cases, organizations leveraging event-driven serverless patterns for specific workloads have seen cost reductions exceeding 70% due to the precise resource allocation and pay-per execution models. So perhaps more importantly, these organizations experience a 40% boost in the developer productivity by eliminating infrastructure management tasks. This translates to fast innovation cycles and significantly reduced time to market for new features. So studies indicate that serverless adoption can accelerate feature deployment by up to 50%, enabling business to respond rapidly to market changes. Furthermore, the inherent scalability of serverless architecture leads to a 20 to 30% improvement in application resilience, including downtime and enhancing the user experience. So beyond the cost and productivity, serverless architectures contribute to improved scalability, which means like applications automatically scale based on demand, handling sudden spikes in traffic with minimal manual intervention, or in cases no manual intervention at all. This can lead to a 5 times more increase in peak traffic handling capacity compared to traditional architectures. So reduced time to market. Developers focus on code, not infrastructure, leading to a faster development cycles. Companies have reported to 25% decrease in the time required to launch these new products or features. Enhanced operational efficiency. With managed services handling tasks like patching and scaling, operation teams can focus on strategic initiatives. This can result in a 15 to 20% reduction in operational burden. Increased agility and flexibility. Serverless enables rapid prototyping and experimentation, facilitating agile development practices. Organizations find that they are able to test and deploy these new ideas 30% faster. Environment sustainability. Pay-per-use models reduced wasted resources, contributing to a more sustainable computing practices. So this one study estimated a potential 10 to 20% decrease in the energy consumption for certain workloads when migrated to serverless. Global reach. The serverless platform often provide a built-in global distribution, simplifying the deployment of applications to multiple regions. Some services report latency reductions of 40% when moving to a global edge-based service, serverless location. Simplified microservices implementation. Serverless functions are ideal for building microservices, allowing for a granular scaling and independent deployments. Organizations see up to 35% decrease in complexity of managing microservice deployments, event-driven architecture adoption. So serverless aligns naturally with event-driven architectures, enabling real-time data processing and asynchronous workflows. This has been shown to improve real-time processing speeds by 20 to 50% in certain use cases. These benefits collectively contribute to more agile, cost-effective, and scalable development environment, empowering organizations to innovate and compete effectively in the digital landscape. So when let's try to understand a bit more about the monolith challenge. Monolith SaaS applications create significant obstacles that severely constrain the business agility and market responsiveness. Their tightly coupled components establish a critical development bottleneck, where even minor modifications require comprehensive testing across the entire application, dramatically extending release cycles from days to weeks or months. Specifically, a study found that companies utilizing monolithic architecture experienced an average release cycle of 12 weeks for new features compared to 3 weeks for those using microservices. This translates to a 75% reduction in deployment speed. Furthermore, regression testing for a single feature change in a monolithic application can consume up to 40% of development time, diverting resources from innovation. The fundamental inability to scale independent components leads to substantial resource inefficiency, forcing organizations to over-provision infrastructure to accommodate peak demand scenarios. For example, a typical e-commerce platform using a monolithic architecture might allocate a server capacity for a Black Friday level traffic year-round, resulting in an average of 60 to 70% of idle resource utilization during normal operations. This over-provisioning leads to 30 to 50% increase in infrastructure costs compared to architectures that will allow for granular scaling. Moreover, the lack of independent scaling often results in degraded performance during peak loads, with reported latency increases up to 5 seconds, leading up to a 20% drop in user engagement. So additional challenges include technology lock-in. Monolithic architectures often rely on a single technology stack, making it difficult to adopt new technologies or integrate with modern cloud services. This limits innovation and can lead up to 25% increase in maintenance overhead as legacy systems become harder to support. Increased risk of failure. A failure in one component can bring down the entire application, leading to significant downtime. So studies have shown that monolithic applications experience a 40% more downtime incidents compared to microservices-based architectures. Difficulty in onboarding new developers. The complexity of a large code base makes it a challenge for new developers to understand and contribute, resulting in a 30% increase in onboarding time. Limited ability to implement continuous delivery. So the long release cycles associated with monolithic applications hinder the adoption of continuous delivery practices, slowing down the feedback loop and delaying the time to market. Organizations report a 50% decrease in the ability to deliver small, frequent updates, reduced innovation velocity. The complexity of changing the code and the risk of associated with changes slows down the rate at which the new features can be added. One study indicated a decrease of roughly 20% in the number of new features released per year. Database contention. Monolithic applications often rely on a single database, which can become bottleneck as the application scales, leading to the performance degradation. So this can limit the application's ability to handle high transaction volumes. Database contention has been shown to cause 15 to 25% reduction in transaction throughput. These limitations underscore the need for more flexible and scalable architectures such as microservices or serverless to meet our demands for the modern SaaS applications. Now, let's take a look at decomposing the monoliths into microservices. So these transformation of microservices require a thoughtful decomposition based on business domains rather than technical layers. Studies suggest that organizations that focus on business domain decomposition see a 30 to 40% reduction in integration complexities post-migration. Identify the service boundaries. So we need to map the functional domains and business capabilities to establish clear service boundaries using domain-driven design principles and event storming techniques. Effective boundary identification through event storming and context mapping reveals a natural service demarcations that aligns with organizational structures and business capabilities. Specifically, utilizing event storming workshops can reduce service boundary definition by 20 to 25% and improve alignment with business stakeholders. Research indicates that well-defined service boundaries result in 15 to 20% improvement in the team autonomy. So define the service interfaces, create robust, well-controlled version APIs with well-documented contracts that enforce loose couplings and enable independent service evolution. Organizations implementing API first strategies reported 35 to 40% increase in the development speed due to reduced dependency. Adopting open API specifications can reduce the API documentation efforts by up to 50% and improve developer onboarding. Furthermore, the version control of APIs has shown to decrease breaking changes up to by up to 25%. So refactor incrementally extract services systematically through the strangler pattern, prioritizing high-value, low-risk components while maintaining the system stability. Successful migrations leverage the strangler pattern methodology, systematically replacing the monolithic functionality while preserving the system integrity. Implement a service mesh. Deploy sophisticated service discovery and communication layer that enables resilient inter-service communication, circuit breaking, and observability. A single mesh can improve latency by up to 10 to 20% and reduce service failure rates by 25 to 30% through features like circuit breaking and retry policies. Implementing comprehensive observability with a service mesh leads to a 40 to 50% reduction in the mean time to resolution. It's called as MTTR for service-related incidents. Additional points to consider while decomposing the monoliths into microservices could be organizational alignment. Ensure the microservice architecture designs aligns with the organization structure and culture. That's fit is more important. Automation. Automate deployment, testing, and monitoring of to enable the continuous delivery and reduce the manual errors. So implementing the CI/CD pipelines can decrease the deployment times up to by 60 to 70%. Security. Implement robust security measures, including authentication, authorization, and encryption to protect the inter-service communication. Monitoring and observability. Implement comprehensive monitoring and logging to gain insights into the service performance by identifying potential issues. Database management. Address database management challenges by considering patterns such as database per service or shared database with careful schema design. So by focusing on these principles and incorporating data-driven designs, and organizations can effectively navigate the complexities of microservices migration and unlock the benefits of increased agility, scalability, and resilience. Now, let's take a look at a couple of the AWS services. The first one would be the AWS Lambda, the serverless foundation. AWS Lambda serves as the computational cornerstone of the modern serverless architectures, executing code in response to events with zero server provisioning or management overhead. This paradigm shift fundamentally transforms the economics of cloud computing by implementing a consumption-based pricing model that changes precisely for the compute resources consumed. Studies indicate that the organizations shifting to Lambda-based architecture experience a 60 to 80% reduction in the operational overhead related to server management. Event-driven executions functions instantly activate in response to triggers from AWS services, completely eliminating idle resource consumption and delivering true pay-per-use computing with millisecond precision. In typical event-driven scenarios, Lambda functions demonstrate a cold start latency of under 100 milliseconds in 90% of invocations, and subsequent warm invocations achieve latencies below 10 milliseconds. This precision in resource allocations leads to a 20 to 30% reduction in overall compute cost compared to traditional VM-based event processing. Automatic scaling. Lambda seamlessly scales concurrent executions to match the real-time workload demands without any configuration overhead, effortlessly handling everything from a single request to thousands per. Lambda can scale to handle sudden spikes in traffic, achieving a 99.99% availability rate, and can scale from 0 to thousands of concurrent executions in seconds. Auto-scaling capabilities have been shown to reduce the peak load latency by 40 to 50% compared to manually scaled systems. Polyglot support. Developers can gain freedom by leveraging multiple programming languages across different functions, empowering teams to select the optimal technology stack for each specific microservice. The flexibility has been reported to decrease the development time by 15 to 25% as teams can utilize preferred languages and libraries. Furthermore, teams report a 10 to 15% increase in code maintainability by utilizing the right tool for the job. With Lambda millisecond billing granularity and zero friction scaling capabilities, organizations can achieve unprecedented optimization compared to traditional always-on server instances. Enterprises typically realize a 70 to 90% reduction in compute costs for appropriate workloads after migration, while simultaneously improving responsiveness and eliminating capacity planning concerns. Additional data points and benefits include reduced time to market, improving default tolerance, simplified operational complexity, enhanced security, like cost optimization for intermittent workloads, integration with AWS ecosystem, and global scalability. By leveraging these benefits, organizations can achieve a significant cost savings and improve operational efficiency and accelerate innovation. Now let's take a look at the key AWS serverless services. So AWS builds a robust ecosystem of serverless services that work harmoniously with Lambda to create powerful cloud native solution. So let's take a look at Aurora Serverless. Dynamically adjusts the database capacity in response to application demands without server management overhead. So studies have shown that the Aurora Serverless can reduce database cost by 30 to 50% for applications with variable workloads. It auto scales database capacity when within seconds, maintaining a consistent performance and reducing the need for manual capacity planning. For application with unpredictable traffic patterns, Aurora Serverless has been reported to decrease database administration time by up to 60%. API Gateway simplifies the creation of secure, scalable RESTful APIs that seamlessly trigger Lambda functions. API Gateway can handle millions of API calls per second, ensuring high availability and low latency. Utilizing the API Gateway reduces development time for API creation by 20 to 30% and provides built-in features for authentication, authorization, and request validation. API Gateway caching features can reduce the backend load up to 80% for frequently accessed data. Event Bridge. So Event Bridge transform application architecture by providing serverless event bus that intelligently routes events between decoupled services and third-party SaaS providers with minimal configuration. Event Bridge can process millions of events per second with near real-time latency, typically under 500 milliseconds. It simplifies integration with third-party SaaS applications, reducing integration time by 40 to 50%. Event Bridge filtering and routing capabilities reduce the complexity of managing event-driven architectures, decreasing development efforts by 25 to 30%. S3. S3 is called a simple storage service. It provides durable object storage that integrates seamlessly with Lambda and other serverless services. S3's high durability is with 99.99s and availability of 99.99% make it ideal for storing and retrieving large volumes of data. S3 event notifications can trigger Lambda functions, enabling real-time data processing and analysis. Organizations utilizing the serverless architectures with S3 for data storage have reported a 20 to 30% reduction in storage costs compared to traditional storage solutions. CloudWatch offers sophisticated observability capabilities, providing monitoring, logging, and alerting for serverless applications. CloudWatch logs allows for real-time log analysis, reducing troubleshooting time by 30 to 40%. CloudWatch alarms can automatically trigger Lambda functions or other AWS services in response to performance metrics, enabling automated remediation. CloudWatch dashboards provide a centralized view of application performance, improving the visibility and reducing mean time to detection by 25 to 35%. So additional benefits and data points to consider would be simplified microservices architecture, the cost optimizations, increased development velocity, enhanced security, streamlined CI/CD pipelines. So by leveraging these comprehensive ecosystems, organizations can build highly scalable, cost-effective, and resilient serverless applications that drive the innovation and business growth. Let's take a look at the real-world success stories. A fintech transformation, a leading financial service provider slashed infrastructure costs by 45% while accelerating the time to market for new features from months to mere days by migrating their transaction processing system to Lambda and DynamoDB. They achieved unprecedented operational efficiency and customer responsiveness. So a healthcare analytics platform revolutionized their operations by implementing serverless architecture that scales instantaneously during peak reporting periods. This eliminated persistent performance bottlenecks while delivering a remarkable 52% reduction in operational expenditure, allowing resources to be redirected toward patient care initiatives. Retail recommendation engine. An e-commerce retailer reimagined their recommendation engine using serverless microservices, dramatically reducing the response time from 2 weeks to just 200 milliseconds. This 10 times performance improvement drove the substantial 30% increase in conversion rates through hyper-personalized shopping experience that adapt in real time to customer behavior. These transformative case studies illustrates the profound impact of serverless architecture across diverse industries. Beyond mere technical improvements, organizations consistently report enhanced business agility, substantial cost savings, and newfound capacity to rapidly innovate and respond to market opportunities that were previously unattainable with traditional infrastructure. Let's take a look at DevOps, CI's continuous improvement and continuous delivery for serverless. So, serverless architectures require sophisticated DevOps approach that fundamentally embraces infrastructure as a code principles and fully automate development pipelines. So, AWS code pipeline seamless integrates with Lambda to enable comprehensive continuous delivery workflows that deploy functions. So, API configurations and database schema changes are as unified atomic unit. Studies shown that organization adopting to mature serverless DevOps practices see a 40 to 50% reduction in deployment related errors. Infrastructure as code codify services resources with AWS CloudFormation or the serverless framework to guarantee reproducible version called as infrastructure deployment across environment. They are version controlled and it reduces manual intervention errors up to 60 to 70% and accelerates environment provisioning by 50 to 60%. Version controlling IAC templates with Git ensures auditability and enables rollbacks, reducing recovery time by up to 30%. Automated build pipeline. To establish a robust continuous integration with AWS code build to automatically compile, package, and validate Lambda functions with the dependencies. Code build reduces build times by 70 to 80% compared to manual process. Automated dependency management system ensures consistency and reduces works on my machine issues by 40 to 50%. Static code analysis and security scanning with pipeline have been shown to reduce vulnerabilities by 25 to 30%. Comprehensive testing. Deploy ephemeral test environments for thorough unit integration and performance testing of individual functions end-to-end workflows. Ephemeral testing environments reduce test environment setup by 80 to 90% and improve test reliability. Automated performance tests can detect regressions early, reducing the latency issues in production by 20 to 30%. Implementing contract testing for APIs ensures service compatibility, reducing integration errors by 15 to 20%. Stage deployments. Leverage AWS code pipeline with canary deployment strategies to methodically introduce changes while continuously monitoring for anomalies and performance impacts. Canary deployments reduce the risk of widespread failures by 90 to 95% and enable rapid rollbacks in case of issues. Automated anomaly detection with CloudWatch alarms reduce mean time to detection by 35 to 45%. Stage deployments combined with feature flags reduce the impact of failed deployments by up to 50%. Industry-leading organizations implement sophisticated stage deployment strategies with intelligent rollback capabilities, preserving the system integrity while dramatically accelerating release cadence. This transformative approach has enabled the forward-thinking companies to achieve deployment frequencies measured in hours, sometimes minutes, compared to the weeks or months required with traditional infrastructure models. Specifically, organizations using automated serverless CI/CD pipelines report a 70 to 80% reduction in deployment times. Let's take a look at securing the serverless applications. Security in serverless applications require a shift in approach from traditional infrastructure protection to function level controls. Each Lambda function should operate with minimal permissions, allowing the principle of least privilege, with carefully defined IAM roles. Studies indicate that the organization implementing a fine-grained IAM roles reduce the risk of lateral movement after a security breach by up to 40 to 50%. Function-level IAM roles implement fine-grained permission boundaries by using the principle of least privilege for each Lambda function, restricting access to only required resources. Implementing function-level IAM roles reduces the attack surface by 20 to 30% compared to broad service-wide roles. Utilizing the IAM policies with resource-level permissions reduces the impact of compromised credentials by up to 35%. Secrets management. Restore the sensitive configuration in AWS Secrets Manager with automatic rotation and secure retrieval by authorized functions only. Secrets Manager reduces the risk of hard-coded credentials by 60 to 70% and automates secret rotation. Reducing the window of vulnerability, implement the least privilege access to Secrets Manager, ensures that only authorized functions can retrieve more sensitive data. Input validation, implement strict schema validation of API at API level boundaries, using the API gateway request validators to prevent injection attacks. API gateway validation reduces the risk of a SQL injection and cross-site the scripting attacks by 30 to 40%. Implement input validation at the API layer, reduces the load on Lambda functions, improving performance and security. Dependency scanning. Integrate automated vulnerability scanning into CI/CD pipelines to detect known vulnerabilities in third-party dependencies. Dependency scanning reduces the risk of exploiting known vulnerabilities by 25 to 35%. Implementing software composition analysis SCA tools in CI/CD pipelines reduces the time to identify and remediate vulnerabilities. Data protection remains critical with encrypted requirements for both data in transit and at rest. AWS provides tools like KMS for encrypting key management partners and partner store for securing configuration, enabling a comprehensive security posture for serverless applications. So the additional data points and security practices to consider would be network segmentation, runtime security, and logging and monitoring, security audits, immutable deployments, ensuring that the Lambda function deployments are immutable, preventing unauthorized modifications. Web application firewall rules, encryption at rest and in transit, regular security updates. This is keep all the dependencies and runtime environments up to date with the latest security patches. Automated patches reduces these vulnerability windows as well. By implementing the security practices, organizations can build secure and resilient serverless applications that protect sensitive data and minimize the risk of security incidents. Business intelligence integration. Integrating business intelligence tools with serverless architectures creates opportunities for real-time decision-making. Analytics pipelines built on event principles can process data as it gets generated, eliminating the batch processing delays and providing immediate visibility into business operations. Studies show that the organizations adopting serverless analytics pipelines reduce data processing latency by 60 to 80% compared to traditional batch processing. Real-time analytics pipeline. Serverless architectures enable event-driven analysis pipelines that process real-time data, delivering immediate insights rather than delayed batch processing. Event capture via Event Bridge. Event Bridge allows to capture the real-time events from various AWS services and SaaS applications. Streaming processing, which enables real-time data ingestion and processing. Kinesis data streams can ingest and process terabytes of data per hour, providing real-time data flow. Kinesis data analytics allows for a real-time SQL queries on streaming data, reducing the need for complex transformation. Transformation with Lambda functions perform real-time transformations and enrichments. Lambda functions can process events within milliseconds, enabling the real-time data processing. Lambda functions can integrate with machine learning models for real-time data analysis. Storage in data lakes or warehouses. S3 data lakes and Redshift data warehouses provide scalable and cost-effective storage for processed data. S3 data lakes can store petabytes of data, enabling large-scale data analysis. Redshift data warehouse provide fast query performance for complex analytical queries. Visualization with QuickSight. QuickSight provides interactive dashboards and visualizations for real-time data exploration. QuickSight can generate interactive dashboards in seconds, enabling real-time data analysis. Amazon QuickSight pay-per session pricing model. QuickSight's pay-per-session pricing model reduces cost intermittent users. Organizations report a 20 to 30% reduction in BI infrastructure compared to traditional licensing model. Direct integration with AWS data sources. QuickSight seamlessly integrates with AWS data sources, reducing the data preparation time. ML-powered insights. The QuickSight's machine learning capabilities provide automated insights and anomaly detection. ML-powered insights reduce the time to identify anomalies by 30 to 40%. Embedded analytics capabilities. QuickSight embedded analytics features enable seamless integration of dashboards into applications. Embedded analytics improve user engagement by providing data insights within the application context. Business outcomes. The integration of serverless analytics delivers a tangible benefits beyond technical improvements, driving a better business decisions. 30% faster time to insight, reduced analytics infrastructure cost, democratized data access. Serverless analytics enables self-data exploration, empowering business to access data without IT intervention. Improved customer experience. Real-time insights enable personalized customer experience and proactive service improvements. Real-time data-driven responses improve customer satisfaction score by an average of 15 to 20%. By leveraging these capabilities, organizations can unlock the power of real-time data and significant business values. So let's talk about our serverless migration roadmap. So begin your serverless journey with a comprehensive assessment of your current architecture, identifying the components suitable for initial migration. Studies indicate that the organizations that perform a thorough assessment before migrating see a 20 to 30% reduction in migration-related issues. The ideal candidates are stateless services with variable workloads that benefit from Lambda automatic scaling and pay-per-use pricing model. Specifically, services with intermittent traffic patterns or event-driven workflows have shown to yield a 40 to 60% cost reduction when migrated to serverless. Initial assessment and component selection. Identify the stateless services such as API endpoints or data transformation tasks are ideal for Lambda. Analyze workload patterns. Identify services with variable or unpredictable workloads. Services with a peak to throw traffic ratios of 5:1 or higher benefit significantly from serverless scalability. Evaluate cost savings potential. Calculate the potential cost savings by comparing current infrastructure cost with estimated Lambda execution cost. Assess complexity and dependence and consider the data processing pipelines. Pilot project, and the next step would be the pilot project and foundational elements. Start with a pilot project. Begin with a pilot project to build team experience and validate your approach before broader adoption. Build a team experience. Pilot project helps teams to gain hands-on experience with the serverless technologies and best practices. Validate your approach. Use the pilot project to validate your infrastructure as code templates and CI/CD pipelines. Create reusable patterns. Focus on creating reusable patterns and infrastructure as code templates that accelerate future migrations. Establish foundational elements. Define standards and best practices for serverless development. Securing and operations. Standardized practices reduce operational overhead by 20 to 30%. Implement observability. Implement CloudWatch and other observability tools to gain insights into application performance. Organizational change and upskilling. Invest in upskilling. Remember that serverless transformation is both a technical and an organizational change. Invest in upskilling your teams to maximize the benefits of this architectural shift. Foster a DevOps culture. Promote a DevOps culture that emphasizes automation, collaboration, and continuous improvement. Empower autonomous teams. Organize teams around business capabilities, fostering autonomy and ownership. Encourage experimentation. Create a culture of experimentation and learning, allowing teams to explore new serverless technologies. Establish a center of excellence. Create a serverless center of excellence to provide guidance, best practices, and support for teams adopting serverless. Address security concerns. Proactively address security concerns by implementing function level IAM roles, and other security best practices. By following these guidelines, organizations can navigate their serverless journey to unlock full potential of this transformational or architectural approach. Yeah. Thank you so much. To conclude, we have seen how AWS serverless architecture empowers us to move beyond the limitations of monolithic SaaS. By embracing the microservices, Lambda, and automated pipelines, we unlock potential substantial cost reductions, accelerate the development, and enhance security and scalability. This transformation requires a strategic approach, assessing your architecture, piloting key services, and investing in team upskilling. The data speaks for itself. Organizations adopting serverless experience have seen significant improvements in efficiency and speed. Let's leverage the power of AWS to build agile, resilient, and cost-effective SaaS applications, driving the innovations and achieving tangible business outcomes. Thank you so much for listening to my presentation. I hope you have gained some insights into the world of transforming monolithic into a cloud-based approach like AWS, Amazon Web Services. If you have any questions, you can always reach out to me at Srikar@gmail.com. I'll be more than happy to talk about this presentation or anything in general. Thank you so much. Thanks again.